Now, you're going to look at the sheet, and I'm going to tell you right now we need to have all of this memorized. I'm going to tell you we know most of this stuff, kind of. And the stuff we don't know, we can learn. So look at the reciprocal identities. As long as you know that sine and cosecant are buddies, you should already know this one. That sine x can always be rewritten as 1 over cosecant x. Just like cosine can be rewritten as 1 over secant, tangent can be written as 1 over cotangent, and then we can go the other way. Cosecant is 1 over sine. Secant is 1 over cosine, and cotangent is 1 over tangent. Those should be things that don't need to be memorized. They're things that we should know. The only thing that really happens is we mess up cosecant and secant and put them with the wrong ones. Now's the time to really iron that out and get that down. We've also already talked about tangent. We talked about tangent being sine over cosine. Well, that means cotangent must be equal to cosine over sine because those are reciprocals of each other. Now, here's my hint for these two. Cotangent and cosine. I always think about this. Cotangent equals cosine over sine. Cotangent equals cosine over sine. It helps me remember that. And if I know what cotangent equals, that helps me remember tangent. So if someone asks me what tangent equals, I still to this day first think about cotangent first. And I go, okay, cotangent, cosine over sine. So, oh, tangent is sine over cosine. So cotangent is cosine over sine. If you just have that mantra to yourself, cotangent, cosine, it'll even help you on the Pythagorean identities a little bit as well. So cotangent, cosine over sine. Odd evens, these are weird ones. We're going to talk a little bit more about it tomorrow. These need to be memorized. And that is the fact that if I take sine of a negative angle, let's say I do sine of negative 30 degrees. That's the exact same thing as if I did negative sine of 30 degrees. They're both going to be, or not 30 degrees, yeah, of 30 degrees. They're both going to be negative 1/2. Whether I have the negative sign inside or outside, you'll get the exact same value. Well, since sine and cosecant are buddies, same rule applies for cosecant. Whether the negative's in the inside or the outside, you're going to get the exact same answer. The one you need to really focus on, the weird one, is cosine and secant. This is the one I focus on because it's the one that's different. For cosine, if I ask you for cosine of negative 30 degrees, what do you get out? If you looked at your unit circle and said, what's the cosine of negative 30 degrees or negative pi over 6? What would you get out if I asked you for the cosine of negative pi over 6? I would get square root of 3 over 2, a positive square root of 3 over 2, right? Yes. Because what's the cosine of 30 degrees? What's the cosine of 30 degrees? Square root of 3 over 2. So whether I have a negative in here or a positive, you're going to get the exact same value out. So that means if I ever write cosine of negative x, you can just write it as cosine of positive x. They're equal to each other. The same thing's going to apply for secant. So to go from cosine of a negative value, if I want to get rid of the negative sign, I can just erase it for cosine. I can do the same thing for secant. These are the only two you can do that for. For everything else, so like tangent, you have to bring it out front. For cotangent, you have to bring it out front. So if I want to rewrite this, I can rewrite it as long as I put the negative sign on the outside, and you'll get the exact same value out. So the tangent of negative 30 degrees is the exact same value as negative tangent of 30 degrees. But like I said, I focus on this one. Know the weird one, the one where you can just erase it and it's equal to each other, and then you'll know everything else is going to be, you have to pull it out front. So these are some rules. Now, the next set of things that we need to have memorized, and it starts with this guy right here. Sine squared plus cosine squared equals 1. You have to know that. You have to know sine squared plus cosine squared equals 1. You have to know that. The other ones we can figure out. I'm going to show you how to figure those out, but we can figure those out. But it starts with sine squared plus cosine squared equals 1. Now, the next one I always remember is the cotangent goes with cosecant. 1 plus cotangent squared equals cosecant squared. Notice how cotangent always goes with co something. Here we have cotangent equals cosine over sine. Here, cotangent squared works with cosecant squared, as long as you remember the 1 goes on the left-hand side. That means tangent goes with secant. We have 1 plus tangent equals secant. Obviously, they're both squared. Variations. We're not going to memorize variations. I just want to show you there's different ways to rewrite these things. So variations can be, see how I have sine squared plus cosine squared equals 1? What if I'd subtract sine squared from both sides? All of a sudden, I'd be able to rewrite this as cosine squared x equals 1 minus sine squared x. That's just me subtracting sine x from both sides. I could have subtracted cosine from both sides. So that could give me sine squared x equals 1 minus cosine squared x. I could do the same thing for tangent. I could, I don't know, move the 1 to the other side, which would give me an equation that looks like tangent squared x equals secant squared x minus 1. And you can see we can always move things around to create specific situations to help us solve things. So these variations, don't memorize them. I just want to show you that we can move stuff around. What's going to be important for you is anytime you see like a sine squared or a cosine squared, what I do is I write this down and I can see if I can manipulate it to fit a specific situation. Because this chapter is all about changing how things appear. Either it's simplifying them or showing that they're equal to each other. This chapter, or what we're working on right now, is actually simplifying things. So this whole chapter is about changing the appearance of things by using these key identities. So let's do some changing of things. Let's consider the point on the unit circle x, y. So we have a point on a unit circle that's at the point x, y. In fact, I'm going to go ahead and I'm going to draw that triangle really quick next to it. So we have a unit circle. That's a terrible right triangle. Let's see if I can make that better. All right, so we have a unit circle, which means that this length is 1. And we have a point x, comma, y, which means we move right x and up y. Remember that Pythagorean theorem we had? Yes. A squared plus b squared equals c squared. Well, if I can focus on that here, we have a squared plus b squared equals c squared. Well, in this particular case, our sides are x and y. So breaking that apart, would that make sense that y squared plus x squared equals 1 squared? Does that follow the logic of a squared plus b squared equals c squared?
Yes. Yeah.
Yeah. Okay. On our unit circle, what does y represent? That might be a terrible way to phrase that question.
Sorry.
It does. Yeah. It represents sine. So rather than picturing that as y squared, let's go ahead and call this angle theta right now. Instead of y squared, we throw in sine. So it's sine squared theta plus an x stood for, if y is sine, that means x is cosine. So we have cosine squared theta. Just equals 1. This right here is why sine squared plus cosine squared equals 1. It comes all the way back to geometry class where we learned that a squared plus b squared equals c squared. So now we have to know the fact that sine squared plus cosine squared equals 1. And that's what they talk about right here. Upon substitution, we end up with sine squared plus cosine squared equals 1. Now theta, alpha, x, they all mean the same thing. These are just variables. Remember, if you don't like alpha or theta, just change them to x's. I have no problem with that. If it makes it easier on yourself, just change them to x's. All right, now let's tackle the very first two things we're going to change the appearance of. So I'm going to give you sine squared plus cosine squared equals 1. And now I'm going to say divide both sides by sine squared. Well, if you divide both sides by sine squared, it's going to look something like this. So I'm going to divide both sides by sine squared alpha. Divide this by sine squared alpha. Now, just a reminder, when you divide something by sine squared, you divide every element by that. So realistically, what I have right now is I have sine squared alpha over sine squared alpha plus cosine squared alpha over sine squared alpha equals 1 over sine squared alpha. I don't know about you, but that looks more complicated than what we started with. I assume that I'm not having you divide things to make it look a lot more complicated, so let's simplify some of these fractions. Let's simplify the first one. The first one says sine squared over sine squared. What if you ever have something divided by itself? What does that equal?
1.
It just equals 1. Okay, so that's just a 1. So that makes it a little easier, so I just have a 1. Now, the next thing I have is cosine over sine. Now, if you just look up a little bit, we have all these properties that deal with cosines over sines and sines over cosine. What I'm looking for is a specific property. Now, for right now, pretend the squareds aren't there. Is there anything on the identity sheet that talks about cosine over sine? It's going to be cotangent. And since they're both squared, it's going to be cotangent squared. Okay, the next thing I have 1 over sine squared. There should be something up there that says, hey, I can rewrite 1 over sine as something else. What can I rewrite 1 over sine as? We can write it as cosecant. It's buddy. So we can rewrite this as cosecant squared alpha. So remember how I said, if you know this one, you can get the rest of them? I just showed you how you get from here to this one. And that is just dividing everything by sine. That must mean to get the next one, we must divide everything by cosine. Let's see if that works. So my next step is I'm going to go back to that sine squared plus cosine squared equals 1. I'm just going to divide everything by cosine squared. Now I'm going to skip a little bit of a step, realizing that I have to divide everything by cosine squared. Divide this by cosine squared, and divide this by cosine squared. Do we have an identity that talks about sine over cosine? We have tangent. Tangent equals sine over cosine. So sine squared over cosine squared equals tangent squared. Cosine squared over cosine squared should just be 1. 1 over cosine, does that relate to something on that? It should be secant. Thank you. It should be secant squared alpha, which gets us our other Pythagorean identity. So these three things are called your Pythagorean identities because they come straight for, don't forget the squares on them. It's really important that you have these squares on here. It does not work without these squares. So if I ever say, hey, 1 plus cotangent, what does that equal? It won't equal cosecant. It has to be squared. It has to be part of this Pythagorean identity. These squares are the most important part on those right now. Because you will see things that are like 1 plus cotangent. There's nothing you can do with it unless it's squared. So these squares are really, 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 really important. So look at your sheets and make sure you have your squares on those. In essence, that's all we're doing today. We're just rewriting things and simplifying them. So the big thing we're doing today, notice how it says we're going to simplify these trig expressions. We're going to learn one way to simplify trig expressions today. And what we're going to work on today, remember this is just one way of doing it. We're going to learn other ways to do it as well. One way to simplify trig expressions is to change everything into sine and cosine and then let the dominoes fall. So one way we can do this is we can change everything to sine and cosine. I am going to note that doesn't mean your answer is going to be in terms of sine or cosine. We're just going to change everything and see what we can do from there. So we're going to change everything to sine and cosine, and then we're going to simplify from there. So for a quick example, see how this is all in terms of sines and cosine? But when I simplify it, it's no longer in terms of sine and cosine. So we might change everything to sine and cosine, and our answer might be in tangent and cotangent. It's just whatever we can simplify it to. So for example, I have tangent x over secant x. Do we have things that aren't in sine and cosine? Yes. And if you look at your sheet, you could turn anything into sine or cosine. Any trig thing I give you, I can turn it into either sine, cosine, or a combination of those two. So if I give you tangent x over secant x, I'm just going to make sure if I got plenty of room for this one. Sure. We're going to say that equals, how can I rewrite tangent in terms of sine and cosine? Raise your hand. Don't shout it out. How can I rewrite tangent in terms, don't shout it out, please. Guys, sir? That would be sine over cosine. So I'm going to rewrite tangent x as sine x over cosine x. And I'll put a bigger equal sign, or a bigger division sign to say, okay, that's my tangent. Someone else, what does secant x equal in terms of sine or cosine? Seabass. That is 1 over cosine. We're going to simplify this two different ways. So don't go into this thing. I'm going to write this two different ways to show us two different ways we can simplify this. So I'm actually going to put, maybe this will be our other method. So I'm going to write the exact same thing down below this. And we're going to solve this two different ways. Now, it's your job to figure out which makes more sense for you. And just stick with it. The first way is the classic keep, change, flip. Keep that top fraction, change the sign to multiplication, and flip your bottom fraction, which is going to look like this. So if I was using keep, change, flip, I'd keep the sine x over cosine x. I'll change the sign to multiplication, and I'll flip the bottom fraction, which would be cosine x over 1. Do I need a common denominator to multiply fractions? No, only for adding and subtracting. For multiplying, you just go straight across. So this is one long equation that says sine x cosine x over just cosine x. Now, notice how sine x and cosine x are attached by a multiplication. Those cosine x's can cancel out as long as it's attached by multiplication. So as long as it's multiplication, we can cross these out, and we end up with just sine x is our answer. Now, I said we could do this another way without using keep, change, flip. Here's something you might want to star, because there are some times where we have to use this method. In this case, we could use keep, change, flip, it's fine. But sometimes we'll have to use this method because there's too much stuff on there we can't keep, change, flip. So a way I can get rid of cosine, so let's say I needed to get rid of cosine in the numerator. I don't want this cosine here. We could multiply the numerator by cosine x. If I multiply the numerator by cosine x, I'd have sine x over cosine x. The cosines would cancel out. Am I allowed to just multiply by anything I want? No, it's not balanced. But to keep it balanced, I can multiply the numerator and denominator by the exact same thing, and then it's balanced. So if I wanted to multiply the top by cosine, I would have to multiply the bottom by cosine. That would give me cosine x over cosine x. What's cosine x divided by cosine x equal? 1. Am I okay? Is it okay multiplying by 1?
Yes.
Yes. Now, remember what's happening here? I'm using this to cancel out this cosine, which means this cosine will actually cancel out the other one, which will give us sine x over 1, which is just sine x. I don't care what method you use on these. I do want to point out that this one sometimes will have to do with this method, because there'll be times where we won't be able to flip it. Like, consider if this was, maybe this was 1 over cosine plus 1. You can't flip that fraction because it's got the plus in there. You can't just flip it. So in that case, you have to use this method. This is a good thing to recognize, that if I need to get rid of a fraction, I can always multiply by its denominator as long as I do it on top and bottom. It's going to be really, really helpful in the future. So keep that in the back of your mind. And then you're done. That's it. That's as simple as we can get. All right, our next one, we have, do I have the right one?
Yeah.
Okay. I have sine x plus cotangent x equals, or times cosine x. Now, your job in this assignment is really just locate things that aren't written in terms of cosine or sine, and that's our cotangent x. That's the only thing we're going to change right now. This one looks easy enough. It actually is a little deceivingly hard. So we're going to have sine x plus cotangent equals cosine over sine. Cotangent equals cosine over sine. Co. Just like 1 plus cotangent equals cosecant squared. Co with cotangent. So cotangent equals cosine x over sine x. I'm going to go ahead and change that cosine right now to just cosine x over 1, just so I can see that multiplication happen. Some people really struggle with that. When they leave the cosine down there, they forget whether it goes on the top or bottom. Cosine x is the same thing as cosine over 1. Now when we multiply straight across, we're going to suddenly have sine x plus cosine squared x over sine x. You'll see I go in between putting, I don't usually put parentheses when I'm doing my work. So you'll see me lose those parentheses at time. I'm glad I did it early. Okay. Does that look simplified to you?
Would you be able to do the transition cotangent to tangent?
We could do part of it. So we could do cosine over sine, but that would bring us back to cotangent. Because whatever we do, we'd go back to where we're doing, because I didn't change enough stuff. But here's a key thing you need to learn about today. See how I have 2 items that are being added? I actually want to add those together. I want to add those together.
So you have to add it to the top and bottom.
Well, we have to create a common denominator. Here's an easy way to create a common denominator. So look at, we have sine x over 1, right? Take the other denominator and multiply the top and bottom by that other denominator. So the way I'm looking at this is, well, I have sine x over 1. I'm going to multiply that by the other denominator, which is sine x. So I'm going to take the other denominator and multiply the top and bottom by that. So I'm going to multiply the top and bottom by the other denominator, sine x over sine x. Plus, I'll have cosine squared x over sine x. What's the other denominator? 1. It's just 1. So normally I wouldn't do this, but since it's my notes, maybe I'll put this in there that I'm doing 1 over 1. These are the other denominator. So I'm going to go ahead and use the other denominator to create a common denominator. All right, now we're going to have sine squared x over sine x plus cosine squared x over sine x. Does anyone want more clarification on this step? Does this make sense? Does anyone want to see that with regular numbers? Are we okay? Don't be modest. Just ask if you just want to see that with, you want to see with regular numbers?
No, where'd you get that?
Where did I get this from? I used the other denominator. You're talking about the pink ones?
Yeah.
I use the other denominator. That's what I meant. Like maybe a more concrete, Ernest, if you look at this, let's say I have 1 over 3 plus 1 over 4. And I needed to create a quick common denominator so I can add those together. Well, I can turn this into 1 over 3 times 4 over 4. I took the other denominator. And now I can add that to 1 over 4 and multiply by the other denominator, which is 3. See how I just took I put the 4 over 4 here, put the 3 over 3 here. Now we're going to instantly have, 4 over 12 plus 3 over 12. And now I have a common denominator. Now it equals 7 over 12. So you just take the other denominator and multiply the top and bottom by it. Is that a little better?
Yeah.
Okay, cool. So very easy way to come up with a common denominator is just take the other denominator, multiply top and bottom for both of them. All right, so now we have sine squared plus cosine squared. I'm sorry, so little quick on that. I have sine squared over sine plus cosine squared over sine. Push those two things together, and all of a sudden I have sine squared x plus cosine squared x all over sine x. Are we okay with all the steps I just did? Here comes, so we did a lot of important stuff. This, important. Being able to cancel things out. Coming up with a common denominator, really important today. The next really big thing you have to understand today, sine squared plus cosine squared. Guys, sir?
You add sine x plus sine x, it just stays sine x.
Yeah, that's how adding works to fractions. So if I added these together, I wouldn't have 7 over 24. I would have 7 over 12, right? That's the whole point of coming up with a common denominator, is so that the denominator doesn't change. It doesn't work like multiplication. Addition, you just add the numerators as long as that is bottom. Sine squared plus cosine squared. What does that equal?
1.
It equals 1. It was the one thing you have to know. When you see sine squared plus cosine squared, you have to say that equals 1. That equals 1 from the identity on your sheet. This right here is all equal to 1. I can replace all of sine squared plus cosine squared with just the number 1. And then all of a sudden I have 1 over sine x. Can I write 1 over sine x in a more simplified way?
Yeah.
How? It equals cosecant x. Did my answer end up in terms of sine or cosine? No. I just use sine or cosine to rewrite it, simplify, and then simplify what that is. That can be where your answer turns out to be sine or cosine, but it doesn't have to be. So I don't want on the homework think that all your answers have to be in terms of sine or cosine. Your job in the homework is to change everything to sine and cosine, and then let the dominoes fall. In this case, they fell until I got to cosecant x. You know, a majority of this unit is just these couple problems. They're more advanced than this, but the same kind of ideas. Yeah.
What's the difference between, like, from A, since we got sine x over 1 equals sine x, and with that one? And that equals cosecant.
This one right here?
Like on A, problem A.
Oh, yep.
I was,
I'm on A?
yeah.
Okay, so notice this isn't 1 over sine x. This is sine x over 1, which just equals sine x. You don't have to worry about, the only time you have to worry about converting it is if it's a 1 on top.
A 1 on top?
A 1 on top, because you can't do that division. Like if I give you, so picture the difference between 2 over 1. How are you going to write that as? 2. 1 over 2, can I write that as 2? No.
Fair, yeah.
So same thing here, sine x over 1, just sine x. If it's 1 over, I got to do something else. Okay?
Okay, fair.
But like I was saying, pushing things together, that's going to be a huge thing for this whole unit. The quicker you understand like this idea, the easier a lot of these problems become. If I have two things and I need to push them together, multiply by the other denominator. When I start seeing squareds and stuff, I need to start thinking about Pythagorean identities. When I start seeing things like this, I can use this method to simplify it. So those are 3 huge things in those couple problems. All right, our last one. It looks more complex than the other one. This one's actually simpler than the one we had above. Let's go ahead and do this. We're going to turn anything that's not in terms of sine or cosine into sine and cosine. So maybe I'll come down here. Can I write tangent in terms of sine and cosine?
Yeah.
I heard a sine x in there. Over cosine x. Cool. Now we're not turning it into 1 over cotangent. We want to turn it into sine and cosine. Cosecant, is that 1 over cosine? Because cosecant, cosine? Oh, it's sine. Cosecant and sine, they're buddies. So this is 1 over sine x. That must mean that secant is going to be 1 over cosine x. There's actually a bunch of different ways to simplify this. Here is the simplest way. First, see if the numerator or denominator can be simplified. Before doing anything else, make sure you can simplify the numerator or the denominator. If you can't, that's when we start doing keep, change, flip, and other things. If I look up here, I have sine over cosine times 1 over sine. Well, if I do this multiplication, I would now have sine over cosine over times sine. These sine x's actually are going to cancel out. You have 1 in the numerator, you have 1 in the denominator, and are attached by multiplication. They're attached by multiplication, so I can cancel those out. Be careful. Did I cross out the 1? Nope, we still have a fraction in the numerator. We still have 1 over cosine x over 1 over cosine x. You could do keep, change, flip, but what's easier is realizing your numerator is the exact same thing as your denominator. If I have the same thing over the same thing, we just equals 1. This just equals 1. Now let's be honest, which one looked harder from the beginning? This one above it or this one? This one probably looked like it was going to be harder. And
Well, I
it's
saw
not.
the space.
Yeah, you saw the space.
That's pretty big space.
Maybe I was just going to put a whole bunch of notes for you.
Yeah.
The space gave it away, but if you're on a test, don't just look at something and skip it because you think it's going to be harder than the other one. Because if I would have skipped that one, or if I would have skipped this one and just focused on that one, I might not have finished, where I could have got to this one. So on the test, don't just look at what's going to be easy or hard. Do that first step. This whole thing is about do that first step and see what it looks like. Yeah.
For this one, could I have started by canceling cosine?
So you're trying to cancel everything at once? I mean, it'll all get canceled.
Yeah, I can just as well.
You'd have to, yeah, you could do that. Yeah. I wouldn't suggest it. You're getting very complicated. It is right, but it can be very complicated in fractions within fractions to understand what cancels out.
Okay.
So although you're right, I don't prefer you doing that. If that makes sense.
So like on this one.
Oh, yeah, the homework? Yeah. Let's all look at the homework. The homework is just change everything in terms of sine and cosine and simplify. Some become more difficult, like if you look at number 6, you're going to have to distribute number 6 first. So it's already in terms of sine and cosine, so your job is to do that multiplication, see how you can simplify it from there. That one's a really good one to focus on. That one comes up with a good hint. Otherwise, go ahead and get started. Ask questions. We have plenty of time to